Hello and welcome to the TMC Newsroom. Thanks for watching. My name is Rich Tehrani. We're in San Jose today. On our program is Manish Muthal, who's the Director of Strategic Planning Networking Components Division of LSI. And Manish, how are you?
Nice. How are you?
Good. I was hoping we could talk a little bit about what your company is doing in the networking division. What's happening?
Sure. So as you know, Rich, we have two primary businesses at LSI, the storage business and the networking business. Now, networking business is one of our key businesses going forward in terms of the growth that we see in the networking traffic and how we play into the networking industry at large, right? If you look at what's really happening in the networking space, it's all about any-to-any communications, right? We're all wanting to kind of communicate over any device, using any service from any location. So LSI's networking business is really built around how do we enable this any-to-any communications.
Okay. Now, from where you sit, in terms of the large customers you have and the large customer base and the experience you have, it would be very useful for the viewers to find out what trends you're seeing in the market.
Absolutely. So if you kind of tie this back into the any-to-any communications theme, right, what you really need to be able to service any-to-any communications is the ability to add more intelligence, more security, and more control into the network. Fundamentally, as we see network traffic grow, as we see storage traffic grow, unless you have intelligence, control, and security at the right places within the service provider and the enterprise networks, you will not be able to cope up with the demand of this any-to-any communication era, right? So our focus has really been on how do we add scalable intelligence, security, and control into the network, and how do we design our product portfolio around delivering on that vision.
And so in terms of the types of customers you have, can we go through that, please?
Yeah, so absolutely. So at LSI, we are focused on some of the largest tier 1 customers. On the enterprise space, customers like Cisco, HP, Juniper. On the service provider space, customers like Ericsson, Nokia, Huawei, ZTE, Alcatel. These are some of the biggest customers that we focus on. And what we're really bringing to the market with respect to adding more intelligence to the network is a new portfolio of devices called as multi-core done right. So if you look at LSI's networking business, you can think of it as 4 primary product lines. One is the multi-core communication processor business. One is the digital signal processor business, the DSP business. Third is the content and security processor business, and the fourth is the the service layer processor business. Okay, so basically, the biggest initiative at LSI is really how about doing this multi-core processors right. And when we talk about multi-core processors done right, we really think about, in order to deliver scalable intelligence to the network, how do you fundamentally redesign the architecture of a multi-core processor such that you can deliver the necessary performance both in the control plane as well as the data plane to scale up to the demands of the network.
And how are you doing that?
Absolutely. So basically, if you look at our multi-core communications processor, which is one of the biggest focus areas within LSI, the way we have designed our multi-core processor architecture is very different than the first generation multi-core processors that you see out there in the industry. The first generation multi-core processors typically take an approach which is called as the symmetric multiprocessing approach. The symmetric multi-core processing approach basically relies on taking a core and having many such cores, which are essentially identical cores, and you use this architecture to do whatever processing you're doing. If you're doing control plane processing, data plane processing for security, or doing application recognition, or doing intrusion prevention, right? Whatever service you're running, you're essentially running it on multiple cores that are symmetric or identical, right? The approach that we bring to the market is basically asymmetric multi-core architecture. And the reason why we do asymmetric multi-core architecture is because we believe that to deliver the lowest latency architecture, to deliver the architecture that has the best performance per watt characteristics and the most deterministic performance, you really need to use an approach where you take a function and you use an engine that is purpose built for that function. So essentially, if you look at our multi-core architecture, it's a combination of different engine architectures where each engine architecture is optimized for a specific function like packet classification or security like crypto processing or deep packet inspection. Okay, so that's fundamentally how our approach is different, and what that gives you is basically it gives you uncompromised control plane performance for scaling your control plane applications like BGP updates or route table updates. At the same time, deterministic data plane performance for essentially applications that are data path intensive.
So traditionally, if you go back in time, we would have to use, let's say, potentially separate boxes to do all of these different things. But you're telling us now that because of the ability to put so many cores inside of a processor and ultimately inside of a box,
yes,
that we're able to actually turn virtually each one of these processors with the appropriate programming into its own little discrete box where it's doing its own functions.
absolutely right. If you look at the evolution of some of these big equipment in the wireless space or the wireline space or even the enterprise space, if you go several years ago, right, each function was done in a separate silicon, right?
Right.
Typically on a separate card. So you
Sure.
have a separate transport card, a separate signal
Sure.
processing card, a separate control plane card.
Sure, if you look at ATCA, for example,
Exactly,
you just
right?
drop boards in.
Exactly, and what we are
Sure.
seeing going forward is the need for a generic hardware architecture where all the blades are identical with a single piece of silicon that can essentially be used either for doing control plane applications or data plane applications or even user plane applications. And for that kind of an architecture, what you really need is an architecture that can deliver on each one of these vectors in a balanced manner. And that's the fundamental difference that LSI brings to this market.
And so the downside is potentially that these asymmetric processors are fixed function, and so you need to know what they're going to do ahead of time, and you really can't, unless you found another application which is very similar.
Excellent question. And the way we address that is basically if you look at any family of equipment, let's say the base stations or the RNCs in the wireless space, or if you look at the switches or the security appliances in the enterprise space, right? Every equipment has essentially a family of devices from the very low end to the very high end.
Sure.
And the performance requirements across different functions can vary significantly from the low end to the high end. The way we address this basically is through the Axia communication processor, which is essentially a combination of all these asymmetric cores working together and having dedicated acceleration engines that can be attached in a seamless way to the Axia communication processor. So now you get the benefits of having all the asymmetric cores in one chip. At the same time, if you needed higher performance for a specific function or a new function that was not included in the Axia communication device, you can actually add one of our standard processors and attach it gluelessly to the Axia communication processor, and that's how you can scale functionality and performance.
Well, it sounds like a fantastic architecture that's not only fixed function in terms of providing solutions effectively, but also allows flexibility, right?
It's all about price, performance, and power scalability, going all the way down to the very low end, like a branch office router in the enterprise, and all the way to the core of the data center.
Fantastic. Well, thanks so much for being on the program. It's been a pleasure meeting you and learning about what your company's been up to.
Thank you, Rich. Thanks for having me.